Recent earthquake in Tibet, in Japan, and in Mexico, within the 15 days of the new year, has everybody on the edge. So basically, we will talk about the earthquakes in detail in today's videos. It will be helpful for everybody who is concerned citizen or UPSC aspirant, any competitive examination where these natural disasters and hazards come into the picture. Okay, so basically, an earthquake, tremor, or trembler is a shaking of the surface of earth resulting from a sudden release of energy in the earth lithosphere that create seismic waves. So basically, students, this particular we will disintegrate this definition that earthquake, quake means trembling. If earth is trembling, it is called earthquake. Now, how that earth can tremble, right? Because of the plate tectonics. So we will talk about detail in plate tectonics also. So whenever two plates are colliding with each other, or two plates are moving apart from each other, or two plates are slide past each other, convergent, divergent, and transform boundary, plate boundaries, there is a sudden release of energy, and those waves are coming to our surface, and it is creating the damage to the environment or our earth basically. So our earth lithosphere is divided into several tectonic plates that are constantly moving and interacting with one another. So these interaction can lead to earthquakes. Already we have talked about it, especially convergent and transform boundaries. Okay. So earth lithosphere is divided into several tectonic plates we have already done, and these are the major plates in front of you: Northern plates, South American plate, African plate, Eurasian plate, Indian plate, Australian plate, and Antarctic plate. These are the major plates of the world, and Juan de Fuca, Caribbean, Cocos, Nazca, Somalia, Arabian, Philippines, Scotia, these are the minor plates, and this is also the Pacific plate, is also the major plates. So basically there are 7 major plates in the world, but like Pacific plate is the only plate that is totally oceanic plate. Others are continental plates, remember that. So how earthquakes are coming? As we have seen, that when the plates are moving, the movement, earth is moving, that's why the quakes are there. So there are some movements like fault, normal fault, reverse fault, and strike slip fault. Means when the surface was here and now it is going down because of the plate tectonics, it is called faulting. If the plate is moving like this, it is called reverse fault. If it's moving up, it is called normal fault. And if the land mass is moving slide past, it is called strike slip fault. And there are 2 types of strike slip fault also. First is right, and second is left. So left one is called sinistral and right one is called dextral. So these are the basic terminology you should know before going into the details. Okay, so remember dextral, sinistral, reverse fault, normal fault, and strike slip fault. Okay, because we are creating the basics here. Then, so when all these faulting is going on, student, then what is happening? There is some waves are releasing. Can you see this? These are the seismic wave. These waves are called seismic wave. These white color ones are called seismic waves. Okay. So there are 4 types of seismic waves. First is P wave. These are the fastest seismic waves. These are the first one to arrive. Remember. And let me tell you before that the center from where the seismic, when the energy is releasing from this particular center, the energy is releasing, that center is called hypocenter or focus. Remember. Now we cannot go deep into the earth crust. So suppose that this is our hypocenter and this is our surface. So from here the energy is getting released, and this energy, these waves are traveling to the earth surface. This particular point is called epicenter, and these point is called hypocenter or focus. So this is the difference between hypocenter and epicenter. Remember, always remember, because it has been asked in UPSC examination as well as the UGC net examinations. Okay, yeah, let's move then. So first type of seismic wave is primary waves. These are the first one to arrive. That's why it is called primary waves. These are the fastest waves also. And there are some instruments, there are some devices used to measure the earthquake intensity. We will talk in later stage: seismograph, seismometer, Richter scale, MMI scale. So these are the first waves. Primary waves are the first waves that are detected by the seismograph. Seismograph is the instrument that records the intensity of the magnitude, or we can say intensity of the earthquake, how much energy has been released. Also, these type of waves are called compressional or longitudinal waves. Because compressional and longitudinal, because it is compressing, it is not moving the land, it is inside the land it is going on. See, this is called compression, again tension, again expansion, again compression, again expansion, again compression, again expansion. It is shifting the energy in the horizontal direction along with the longitudinal. So basically, primary waves can move through solid rock as well as the fluids, means liquid. So solid and liquid primary waves can move. Second one is secondary wave. So the name itself suggests S wave, secondary wave. These are slower than the P waves. So P waves are the first one to arrive. In secondary waves will be there. So our seismograph, our early warning systems give us 40-45 seconds of time to save ourselves from the earthquake, because P waves we cannot feel, only seismograph will feel that. Okay, that graph will feel it. Now in 1906, Oldham discovered S waves, that S waves only move through solids, not the liquids. And that's how we got to know that outer core of our earth is liquid form. And after some time again we found out that inner core is solid, outer core is liquid, again solid, again liquid. So it's called layering of the earth. So if you want to know more about the layering, write in the comment box. I will definitely make the video for you. Okay, so S waves are also called as shear waves, because these waves move rocks up and down, also rocks up and down as well as in the side like this. That's why it is called shear wave. And the difference between the length between two waves, like this is the wave, so difference between one wave and like this, the length between two waves are called as wavelength. Remember. Third one is our relic wave. Relic wave is the most dangerous wave actually. So if anybody asks you which of the following is the most dangerous earthquake waves, seismic waves, the answer would be relic wave. Okay, so relic wave was predicted by Lord Rayleigh in 1885. That's why the name is Rayleigh is there. Rayleigh is also scattering also. So we will discuss Rayleigh scattering in some another video. So what is happening in relic wave? Why it is so dangerous? Because it is moving the rocks like this in the elliptical path. So it is very dangerous. Suppose that you are having a snake going on, the snake is love waves and the snake is dancing. So it is moving like this also, and it is like this. It is like this is going on. So it's very dangerous. Our buildings cannot sustain upward movement and side by side movement also. That's why it is so dangerous. Okay. Then our love waves move the ground from side to side like this. But relic wave is moving sideways also along with the up and down also. So these are our fourth waves, like four seismic waves, and this is the result of earthquakes. Can you see this? Because of the surface waves, so primary and secondary is called as body waves, and Rayleigh and love waves are called surface waves. So these are the four types of waves, and this is the result of earthquakes, as you can see. So the plate boundaries we talked about was convergent, divergent and transform. We will talk about plate boundaries in different video in detail, that how exactly. So convergent are the plates where two plates are moving toward, trenches are formed. Divergent, when two plates are moving apart, the ridges are formed. And the transform, when plates slide past each other. Okay, yeah. So I talked about the focus, right? So this is our focus or hypocenter. So when two plates are colliding with each other, so this particular area will have the friction will be there. So this will release the energy, and this energy will be coming out, and this point is called epicenter. Okay, so I already talked about epicenter and hypocenter. Read it. Now there is a concept called Snell's law. So Snell's law say that if suppose this is our point of energy release, okay, so these waves will be traveling like this also, and these will be traveling whole earth like this. So why this curvature is there? This curvature is due to the rotation as well as the density and composition of the rocks present here. So this is why the curvature is there. So this curvature is explained by the Snell's law. Snell's law, just remember the name. It's useful for the UPSC mains geography optional. For GS, you just know the name. That is enough. Okay. Now, what is foreshock, main shock, aftershocks, and earthquake swarms, students? So basically, our main shock, main earthquake is there. So you will feel the tremors before the main shock, that is called foreshocks. And if you feel the tremors after the main earthquake, their intensity is less. Foreshock and aftershock, their intensity is less. So foreshock and aftershocks will be less intense, but the number of aftershocks will be more. In recently, the earthquake happened in Tibet. So that particular area experienced 390 aftershocks, small shocks. So these are called, aftershock. What is earthquake swarm? Earthquake swarm means we are getting small earthquakes, no any major earthquakes, like full month or full year we are getting. We are only getting the few quakes, tremors. So that's why these dots are there. There is no any main shock. So the collection of basically earthquakes are called earthquake swarm. So these four terminologies you have to remember. These two terminologies, isoseismal and co-seismal lines. So isoseismal lines are the lines. Okay, these are the lines. Like earthquake is coming, earthquake has occurred. So if we calculate that these particular areas were the areas where the earthquake intensity was same, that is called isoseismal line. If we are joining all these points together, that is called isoseismal line. And co-seismal line means the points on the map seismic waves arrived at the same time. Suppose that these are the points where seismic waves are at the same time. Intensity can be different. Remember, these are the points where the earthquake arrived at the same time. That is called co-seismal. And if the intensity is same, like magnitude is same, 6.7, 6.7, 6.7, then it is called isoseismal line. So it's the difference between these two terminologies. Okay, remember that. So if anybody is interested in the study of seismic waves, that particular person is reading the seismology. So study of seismic waves is called seismology. What are the devices that we use to measure the magnitude of earth? The first would be seismometer, seismograph, and seismogram. So basically these three are interrelated with each other. They are not exactly different, students. So seismographs are the instruments to record the motion of the ground during an earthquake. Right now, suppose that earthquake is coming. Now there would be a device that will measure the seismograph, like that will measure the motion of the ground like this, that how much this ground is moving, that will be done by the seismograph. Or as you can see in the diagram itself, that first wave will be P, second will be S, and then the big one will be the surface waves. So this is how the seismograph look like. Okay, so this is the earthquake, like this is the earthquake. It is measuring the earthquake. So there are two types of seismograph, students, vertical seismograph and horizontal. So this particular is the example of horizontal. Now if I put it like this vertical, that will become the vertical seismograph. Okay, and this pendulum, this spring is called seismometer. Remember, seismogram, this is seismograph, and this spring, as you can see here, this particular spring is called seismometer. So seismometer is the internal part of seismograph, okay, which may be pendulum or any spring that is used. Generally seismograph and seismometer is same thing, okay, and something is getting recorded This recording is called seismogram. This recording is called seismogram. The device that record this seismograph, the seismogram is called seismograph, and the pendulum that is inside it, that is called seismometer. Okay. Then how much energy was released? Who will calculate that? Which scale will calculate that? That scale will be that magnitude will be calculated by the Richter scale. Okay, Earth's magnitude scale, Richter scale, very famous. And we have these number 2, 3, 4, 5, 6, 7, 8, 9. Okay, so recently, as you say in the initially in the video, that Tibet got 7.1, Mexico got around 6, Japan also got around 6. So 6 and 6 will be falling under the strong, and Tibet will be falling under 7.1, and that's why it is major earthquake. 130 plus people died in that particular earthquake. They happened in recently in the Shigagaste region of Tibet. So these are the scales you have to remember. Next scale is MMI, modified Mercalli intensity scale, earthquake intensity scale. So this is particularly for the damage purpose. Richter scale is for the magnitude purpose, how much energy was released. That's why we got the number 5.1, 6.1, 7.1. And Mercalli scale is for the damage, how much damage that earthquake has done that particular place. That is called MMI scale. Okay, so in 1935, Geological Survey of India divided India's seismic zones. So Zone 5, Zone 4, Zone 3, Zone 2, there is no Zone 1. So Zone 5 will be the very high risk area and Zone 2 will be the low risk zone. This is the map. Earlier, Geological Survey of India used to publish. See, this map was published in 1935. Okay, this map was published in 1935, and now who does that? Now this classification has been done by the Bureau of Indian Standards. Okay, same 2, 3, 4, 5. So can you tell me in the comment box which seismic zone your area is in? Comment in the box. And who is the government agency that monitors earthquake? See, seismic zones were decided by BIS, but which institution published that which area got the earthquake? That is National Center for Seismology. Okay, remember that. So in India also there are many earthquake hotspots. As you can see in the map itself, you will find that like whole this North India is not that much, but this particular region, the foothills of Himalayas are the eco-sensitive zone that is getting the most earthquakes. Why? Because this is our Eurasian plate. This is our Indian plate. Okay, like this. Just in heads up like this. And this Indian plate is colliding into Eurasian plate. That is called convergent boundary, convergent plate boundary. Okay, so basically Indian plate is colliding with the Eurasian plate, and Indian plate is going down, Eurasian plate is going up. That's why we feel the earthquake in this particular area. This is the most earthquake prone area in the Asian region because of Himalayan mountains. That's why we need to preserve the Himalayan ecosystem, because if we will have more discriminate about the Himalayan ecosystem, more and more earthquakes will be there, and the disasters like flash floods, we are putting more and more dams in the name of development. So the dams are also putting pressure. So some fatal earthquakes in India are Indian Ocean earthquake in 2004, Kashmir earthquake in 2005, Greater Bihar Nepal earthquake in 1934, and the Bhuj earthquake in 7.7 earthquake. So see the magnitude. Indian Ocean earthquake magnitude was 9.1 to 9.3. Kashmir earthquake 7.6. Bihar, Nepal earthquake 8.7, and the Bhuj earthquake was 7.7. So these are the fatal earthquakes in India, and this is the condition of Bhuj earthquake. Bhuj. It was happened on the Republic Day, 26 January 2001. And after that, in 2004, this Indian Ocean earthquake came. More than 283,000 people died in that particular earthquake. Because of earthquake, tsunami happened, and because of tsunami, this people were dead in Indian Ocean region, in all the countries who is bordering the Indian Ocean. Okay, so in 2001, Bhuj earthquake came. In 2004, Indian Ocean earthquake came. After that, Indian government established NDMA, National Disaster Management Authority. Okay, his chairmanship is done by our ex-officio chairman is Prime Minister of India. Okay, so basically, that was the Indian contest. If we talk about world, so there is a fault that is created by these boundaries called San Andreas fault. Okay, we talked about fault, right? See, because of these, what is happening? San Andreas fault was formed. This is a very famous, fault, San Andreas fault in North America, sorry, yes. So San Andreas. So what is happening in San Andreas fault, students? So San Andreas, this fault is like a major transform fault. This fault's size is more than this fault is, as you can see, faulting is because of the Himalayas was the result of folding. This is because of fault. This fault is around 1200 kilometers. Okay, and it is going through California, USA. Okay, so basically, this San Andreas fault is a plate. It is a plate between North American plate. This is the North American plate, and this is the Pacific plate. So Pacific plate and North American plate, between these San Andreas fault is there. Okay. So Pacific plate is moving, it is moving northwestward relative to North American plate. So this is our North American plate, and this is our Pacific plate. This is our north, this is our east, this is our west, and this is our south. So it is going into this direction. The Pacific plate is moving like this, and North American plate is moving like this. Okay, so they're getting, it's like a transform fault. Okay, so because of two plates are moving like this, this is called our San Andreas fault. Okay, in 1960, because of this fault, major earthquakes were there in 1960, and still today it is very volatile. Because of this particular fault, this particular area is getting lot of earthquakes every time. Okay, yeah. So there is an interesting fact about faulting and faulting. Suppose that this is the river flowing, there is a fault here. So what is happening, students? Interestingly, we generally made the dam over faulting. So if this plate is going down, if this plate is going up, automatically we got the gravity. So we can make the dam here for the gravity. Automatically, we don't need to put the dam's height so much. Automatically, because the rocks were shifted above, we can make the dam here. Automatically, we can use the nature's gravitational power. This is sometimes we form the dams on the active earthquakes also. Okay, and in India there was one earthquake triggered. The earthquake was triggered by the reservoir. What is reservoir? Suppose the river is flowing. Now we are putting some dam here. So we built the Koyna Dam. It is in Maharashtra, Koyna Dam. Okay, so this particular structure is called dam, and this area, it is called reservoir. Okay, it is called reservoir. It becomes the artificial lake. So don't you think this particular reservoir will have the down weight? Like it will have we can say that lot of water is there. It was not supposed to. we are the people who are responsible for that water here, so that water will put the pressure on the land. Okay, now you know our plate tectonics. Now because of that because of that water, our tectonic plates may move and can result in the earthquake. So that was related to the Koina dam earthquake. And recently, what is happening? China is building the dam on the Brahmaputra river. So this particular photo is the Three Gorges Dam. This is the biggest dam in the world. It is also in China. Now China is building more bigger dam than this one. So again, India is concerned that if what happens if some natural disaster happen, because you know that Himalaya is in the earthquake prone area, earthquake hotspot area. Okay, so I've discussed already about the Brahmaputra's dam, China's plan about in one video. Go check that out. So these are the mitigation strategies that we have to prepare, we have to response, we have to recovery, and that is a mitigation. So first will be mitigation, second would be preparation, third would be response, and fourth would be the recovery. This is how the disaster management happens. You have to remember the cycle. Okay, and as we are moving into the artificial intelligence era, we can see that more and more early warning systems with the help of AI we are integrated into the disaster management of earthquakes. Okay, so use of digital camera, LiDAR scanner, our this drones, high speed communication system. 5G has already arrived. We are preparing for the 6G. AI based softwares, system identification and classification. All these are the technologies we are using to mitigate the earthquake. See, we cannot stop earthquake, but we can prepare for the earthquake, right? So that's all for today. I hope you got the idea how the earthquake formed. You got to know about the various waves. So if you find this video, please like, share and subscribe, and give your suggestions in the comment box. If you're having any doubt, you can ask me in the comment box. I will definitely reply it. Okay, so for that, you have to subscribe the channel, so that such type of more videos that is dedicated for PSC examinations, KPSC examination, IS examination, UGC and NET examination. This will help in all the examinations basically. Okay, so do subscribe again. Thank you so much and see you in the next one. I will wait for your responses. Thank you.